So let's talk about how we actually measure water quality, and what that tells us about the health of aquatic ecosystems. There are two main types of tests, chemical and biological. Both give us different clues about what's going on in the water. Chemical tests. These measure things like dissolved oxygen. Most aquatic life needs oxygen in the water to survive. Low DO? That's a red flag. It could mean pollution, too much organic matter, or stagnant water. pH. This tells us how acidic or basic the water is. Most aquatic organisms like it between 6.5 and 8.5. If it's outside that range, it can stress or even kill certain species. Nitrates and phosphates. These are nutrients, usually from fertilizers or sewage. In small amounts, they're fine, but too much causes eutrophication, which leads to algae blooms, oxygen crashes, and fish kills. Temperature. Colder water holds more oxygen and supports sensitive species like trout. Warmer water can mean lower oxygen and more tolerant, less diverse species. Turbidity. This is how cloudy the water is. High turbidity can block sunlight, mess with photosynthesis, and clog fish gills. Biological tests. Now here's the cool part, bioindicators. These are living organisms that tell us about water quality just by being there, or not. One of the best tools? Macroinvertebrate sampling. These are things like insect larvae, snails, worms, and crustaceans that live in the water. Some are super sensitive to pollution, like mayflies and stoneflies, while others can survive in pretty gross conditions, like leeches or certain worms. So if a stream has a variety of sensitive species, that's usually a sign of clean, well-oxygenated water. But if you only find the pollution-tolerant ones, the water's probably not in great shape. Why conditions matter. Physical, chemical, and biological conditions are all connected. If the water's too warm, too cloudy, or too low in oxygen, certain organisms can't survive. That throws off the food chain, reduces biodiversity, and makes the ecosystem weaker overall. Pollution, erosion, runoff from farms or roads, these all change water chemistry, which changes who can live there, which changes how the whole ecosystem functions. So when we test the water, we're not just collecting numbers, we're reading the ecosystem's report card.